The surface looks calm at first glance, a pale, frozen world drifting silently around Jupiter. But the closer we look, the more something feels wrong. Europa is not just ice, it is moving. Beneath that smooth, cracked shell, something is shifting, pushing, reshaping the surface in ways that should not be possible on a world this cold. Long fractures stretch for thousands of kilometers, crossing and recrossing like scars that never healed. Some are fresh, some are ancient, but all of them tell the same story. Europa is not frozen in time. It is active, and that changes everything. Because far below that icy crust, hidden from direct view, there is something we cannot see, but cannot ignore. An ocean, not small, not shallow. A global ocean, holding more liquid water than all of Earth combined. Dark, pressurized, completely sealed beneath kilometers of ice. And yet, somehow, it is still interacting with the surface above. Cracks open, ice shifts, heat rises, a frozen moon, behaving like a living system. And that is where the mystery begins. Because Europa is not just another icy world. It is a place where the impossible starts to feel real. A world where water exists in darkness, where energy comes from within, where conditions may be just right for something more, something we have not yet seen, something we are not yet ready to understand. And as we look closer, Europa stops being familiar. It becomes something else entirely. A world that should be silent, but isn't. A world that should be dead, but might not be. And the deeper we go, the stranger it becomes. And if you're drawn to these quiet mysteries of the universe, take a moment to subscribe, because out here, the strangest worlds are still waiting to be discovered. At first glance, Europa looks simple. A pale sphere, smooth, quiet, almost untouched. From a distance, it feels like one of the most peaceful places in the solar system. A frozen moon locked in orbit around Jupiter, covered in ice, silent for billions of years. But that first impression is misleading. Because Europa is not still. It has never been still. And the moment you begin to look closer, the illusion breaks. The surface is not smooth, not truly. It is fractured, covered in long, dark lines that stretch across the entire moon. These are not small cracks. They are enormous. Some extend for thousands of kilometers, cutting across the icy crust like scars carved over time. They intersect, they overlap, they twist and turn in patterns that do not follow simple rules. And when you see them up close, you realize something unsettling. This surface has been broken again and again and again. Not once in the distant past, but repeatedly, continuously. On most moons, the surface tells a simple story. Impact craters dominate, ancient marks left behind by collisions, unchanging, permanent. But Europa is different, because when scientists first examined its surface, they noticed something strange. There were very few craters, far fewer than expected, which meant only one thing. The surface is young, not millions of years old, but constantly renewed, reshaped, rewritten. And that should not be possible. Not on a world this small, not this far from the sun. Because small bodies cool quickly. They lose their internal energy. They become inactive, frozen, both outside and inside. But Europa did not follow that rule. Something inside it is still active, still moving, still powerful enough to reshape the entire surface. Those long cracks, are not random. They are the result of stress, enormous stress. And that stress comes from one source: gravity. Europa orbits Jupiter, the most massive planet in the solar system. A world so large, its gravity pulls and stretches everything around it. And Europa is caught in that pull, but not in a simple way, because its orbit is not perfectly circular. It is slightly stretched, elliptical, which means as Europa moves around Jupiter, the strength of that gravitational pull changes, sometimes stronger, sometimes weaker. And this constant variation creates something called tidal forces, forces that stretch Europa, squeeze it, bend it, over and over again, like a slow, endless flexing of the moon itself. Imagine a solid world being gently pulled apart and then released, again and again, for billions of years. That is what Europa experiences. And ice, even when frozen, cannot remain unchanged under that kind of pressure. It cracks, it shifts, it breaks. And when it does, those long lines begin to form. But here is where it becomes strange, because the cracks do not just form, they move. Some of them open and then close again. Others shift sideways, like plates sliding past each other. In some regions, the surface looks almost scrambled, broken into pieces, rotated, moved, and then frozen back into place. These areas are called chaos terrain, and they look exactly like what the name suggests: a landscape where order has been lost, where the surface has been shattered and then reassembled. But not perfectly, not cleanly, just enough to leave behind a record of something powerful happening beneath. Because cracks alone are not enough to explain what we see. Movement requires something more, something beneath the surface, capable of pushing upward, of forcing the ice to shift, of reshaping entire regions. And that leads to one unavoidable conclusion. Europa's crust is not solid all the way through. It floats. Beneath the surface, there is a layer, a boundary, between the frozen crust and something else, something that allows the ice above to move, to drift, to break and reconnect. And that something is liquid. But we are not there yet, not fully, because before we can understand what lies beneath Europa, we need to understand just how unusual its surface truly is. Because everything we see points to activity, but not the kind we are used to. There are no volcanoes, no flowing lava, no visible eruptions, at least not in the traditional sense. Instead, the activity is subtle, hidden, slow, but persistent, and it leaves behind patterns that are unlike anything else in the solar system. Some of the cracks have darker material within them, material that appears to have risen from below, filling the fractures before freezing again. Other regions show ridges, raised lines, running parallel to each other, as if the surface has been pushed upward from underneath, layered, stacked, built over time. And when you follow these ridges, you begin to see something even more complex. They are not isolated. They form networks, interconnected systems of fractures, stretching across the moon, a global pattern, a system that suggests the entire surface is linked, that what happens in one region is connected to what happens elsewhere. And that is when Europa stops looking simple, because now we are not looking at a frozen shell. We are looking at a system, a dynamic, interacting, evolving system, where forces from above and forces from below meet, interact, shape the surface together. But there is something else, something even more unsettling, because despite all this activity, Europa remains incredibly smooth. There are no towering mountains, no deep valleys like those on Earth. The variations in elevation are surprisingly small, which suggests that the surface is constantly being leveled, smoothed, reworked, as if the moon is resetting itself over time, again and again. And that leads to a deeper question. Why? Why would a moon behave like this? Why would it continuously reshape its surface? What process could maintain that level of activity for billions of years? Because this is not temporary. This is not a recent event. Europa has been like this for a very long time. And that means whatever is driving this process is still active today. But there is one more detail that makes Europa even stranger, because the cracks are not just lines. They have color, subtle but visible, reddish tones, brown streaks, traces of something mixed into the ice. And those colors do not come from the surface alone. They suggest contamination, material rising from below and spreading across the ice, material that does not belong to the outer layer, which means the boundary between the surface and what lies beneath is not sealed. It is active, open, at least in some places. And if that is true, then Europa is not just a frozen shell. It is a world where the surface and the interior are connected, where what happens below can reach the outside, and that possibility changes everything. Because now, the surface is no longer just a surface. It is a window, a thin, fractured, constantly shifting window into something hidden, something deeper, something that may hold the real secret of Europa. And as we continue to study those cracks, those ridges, those chaotic regions, we begin to realize something simple but profound. Europa is not quiet. It is not still. It is not frozen in the way we once believed. It is active, restless, a world that refuses to remain unchanged, a world where the surface is only the beginning, and the real story lies just beneath it. Beneath the fractured surface of Europa, there is a silence, not the kind we imagine, cold and empty, but a silence that hides movement, depth, pressure, a world sealed beneath ice, because everything we see on the surface, all the cracks, the shifting patterns, the strange formations, they all point to something below. Something that should not exist in a place this cold, and yet it does. Europa is far from the sun, so far that sunlight alone could never warm it enough to melt ice. Temperatures on the surface plunge far below freezing, cold enough to turn water into solid rock-like ice, cold enough to preserve everything for millions of years, and yet beneath that frozen shell, there is liquid, not small pockets, not isolated reservoirs, but an ocean, a global ocean spanning the entire moon. The idea sounds impossible because water needs heat and Europa does not receive enough sunlight to provide it. So where does that heat come from? The answer is hidden in the same force that fractures the surface, gravity. Europa does not orbit Jupiter alone. It shares its orbit with other moons, Io, Ganymede, massive worlds, each pulling on Europa in their own way. And as they move, their gravity interacts, not randomly, but in a precise pattern, a resonance, a repeating cycle that keeps Europa's orbit slightly stretched. And that stretch is everything. Because as Europa moves closer to Jupiter, the gravitational pull increases. As it moves farther away, the pull weakens. And this constant change creates internal stress. The moon is squeezed, stretched, deformed, not dramatically, not visibly, but continuously. And that constant flexing generates heat deep inside Europa. This process is called tidal heating, and it is powerful because even a small amount of deformation, repeated over billions of years, can produce enormous energy, enough to keep water from freezing, enough to maintain a liquid ocean beneath a frozen surface. Imagine a solid world being gently kneaded over and over again. The interior warms, slowly, gradually, until it reaches a point where ice can no longer remain solid, and it begins to melt. That is what has happened on Europa. But the result is not chaos. It is structure. At the very top, there is the crust, a shell of ice, hard, cold, fractured. But beneath that shell, there is a boundary, a transition from solid to liquid. And below that, the ocean. This ocean is not shallow. Estimates suggest it may be tens of kilometers deep, perhaps even more, deeper than any ocean on Earth, containing more water than all of Earth's oceans combined, and yet completely hidden, sealed beneath ice that may be kilometers thick. But if the ocean is hidden, how do we know it exists? We cannot see it directly. We cannot reach it. And yet, the evidence is overwhelming because the surface tells the story. Those long cracks, they are not just fractures. They are signs of movement, of shifting plates of ice floating above something softer, something that allows them to move. In some regions, the ice appears to have drifted apart, then reconnected, leaving behind mismatched patterns, edges that no longer align, like pieces of a puzzle that have been rearranged. And that only happens if the surface is floating. Other regions show signs of material rising from below, warmer ice, or liquid, pushing upward into cracks, freezing again, and forming ridges, layer by layer, over time. And that suggests that the ocean is not completely isolated. It interacts with the surface, at least in some places, at least sometimes. But there is more, because scientists have also studied Europa's magnetic environment. And what they found was unexpected. As Europa moves through Jupiter's powerful magnetic field, it generates its own response, a secondary magnetic signal. And the only way to explain that signal is with a conductive layer beneath the surface, a layer capable of carrying electrical currents. And what is one of the best conductors in planetary environments? Salt water, which means Europa's ocean is not pure. It is likely filled with dissolved salts, making it more like Earth's oceans, dense, conductive, active. And that changes everything, because now we are not just talking about water, we are talking about a system. An ocean that is heated from below, stirred by tidal forces, connected, at least partially, to the surface above, and possibly interacting with the rocky interior below, because beneath the ocean there is a core, rocky, dense, and potentially warm. And that interaction between water and rock is critical, because on Earth, Some of the most important chemical processes that support life happen at the boundary between ocean and rock, deep beneath the surface, in places where sunlight never reaches, where energy comes from within the planet itself. If something similar exists on Europa, then its ocean is not just water, it is an environment, a place where chemistry can occur, where energy is available, where conditions may exist for something more complex to emerge. But we must be careful, because we have not seen this ocean directly. We have not sampled it. We have not confirmed what is inside. Everything we know comes from observation, from interpretation, from evidence that points in one direction, but does not yet provide absolute certainty. And yet, the consistency of that evidence is difficult to ignore. The surface suggests movement, the cracks suggest interaction, the magnetic field suggests conductivity, the physics suggests heat, and together, they all point to the same conclusion. Europa has an ocean, a hidden world beneath the ice, a place we cannot see but cannot ignore, a place that may be more dynamic than the surface itself. Because while the surface is cold, the ocean below is active. Currents may flow through it, driven by tidal forces, temperature differences, chemical gradients, slow but constant motion in total darkness under immense pressure in a world completely cut off from the sun. And that is what makes Europa so extraordinary, because it challenges something fundamental, the idea that life requires sunlight. Because if an ocean can exist, if energy can be generated internally, if chemistry can take place in darkness, then the possibilities expand far beyond Earth, far beyond what we once believed. Because now, we are no longer looking at a frozen moon. We are looking at a layered world, a surface that hides a secret, a shell that protects something beneath. And that something may be one of the most important environments in the entire solar system. But there is still a barrier, a thick, frozen barrier, separating us from that ocean, preventing direct observation, preventing easy exploration. And until we find a way through that barrier, the ocean will remain hidden. And that is where the mystery deepens. Because knowing something exists is not the same as understanding it. And Europa's ocean is still unknown, still unreachable, still waiting beneath the ice. If Europa were left alone, it would be frozen, completely, solid from the surface all the way to its core. Because at that distance from the sun, there is not enough energy to maintain liquid water, not even close. And yet, beneath its icy crust, there is an ocean, which means something is warming it, something powerful enough to resist the cold, something that should not exist on a world this small. The answer does not come from the sky. It does not come from sunlight. It comes from motion, from interaction, from a constant, invisible struggle between Europa and the massive world it orbits, Jupiter. Jupiter's gravity is immense, so strong that it does not simply hold Europa in orbit. It reshapes it, subtly, continuously. As Europa moves along its path, that gravitational pull changes, stronger when closer, weaker when farther. And this difference creates tension. Europa is not perfectly rigid, It cannot resist completely, so it responds. It stretches, it compresses, it flexes, not violently, but constantly. And that constant flexing generates heat. At first, the idea seems simple, but the scale is not. Because this is not a one-time event, this process repeats with every orbit again and again and again, over millions of years, over billions of years, and even a small amount of friction, when repeated endlessly, becomes powerful. Inside Europa, materials are not perfectly solid. Ice, under pressure, can behave like something softer, more flexible, more capable of movement. And as Europa flexes, that internal motion creates resistance, friction, and friction creates heat. This is tidal heating, and it is the reason Europa is not frozen solid, but the process is not uniform. The heat is not distributed evenly. Some regions warm more than others. Some areas experience more stress, more deformation, more energy, and those variations are reflected on the surface. The cracks we see are not just marks of past activity. They are connected to what is happening now. As Europa flexes, the ice shell above is pulled apart, then pushed back together, opening and closing in a slow, endless rhythm. In some places, the ice is stretched thin, weakened, close to breaking. And when it does break, it creates pathways, channels, connections between the surface and what lies below. But the heat does more than crack the ice. It moves the ocean, because water, when warmed, does not remain still. It circulates. Slow currents form, driven by temperature differences, by density changes, by energy from below. And those currents interact with the ice above, warming it from below, melting it in some regions, refreezing it in others, creating a dynamic boundary between solid and liquid. This boundary is not flat. It is uneven, complex, shifting, and that complexity translates to the surface. Because when the ice above is weakened from below, it becomes easier to break, easier to move, easier to reshape. And that is why Europa's surface looks the way it does, not random, not chaotic without cause, but driven by something deeper, something hidden. But there is another layer to this, because Europa is not alone in experiencing tidal forces. Other moons around Jupiter also feel its pull, but they do not all behave the same way. Some are more active, some less. And that difference comes from a delicate balance, a balance between gravity, structure, and composition. Europa sits in a unique position, close enough to Jupiter to experience strong tidal forces, but not so close that its surface is completely destroyed, flexible enough to respond to those forces, but strong enough to maintain structure. And that balance is what allows tidal heating to be sustained, not too weak, not too strong, just enough to keep the interior active. But there is something else, something even more subtle, because Europa's orbit is not random. It is controlled, locked into a resonance with other moons, a repeating pattern that ensures its orbit remains slightly stretched. Without that resonance, Europa's orbit would eventually become circular. The stretching would stop, the flexing would end, and the heating would disappear. Which means Europa's ocean exists because of a delicate cosmic relationship, a balance of forces between multiple worlds, a system that maintains itself. And that makes Europa even more unusual, because its internal heat is not just a result of its own structure, but of its position within a larger system. But what does this heat really do? Beyond maintaining an ocean, what are its consequences? Because heat is energy, and energy drives change. In the ocean below, that energy may create gradients, differences in temperature, differences in chemistry, and where differences exist, interaction follows. Water moves, materials mix, compounds dissolve, reactions occur, slowly but continuously. And over time, those interactions can become complex, more structured, more organized. On Earth, similar processes occur in deep ocean environments, places where sunlight never reaches, where energy comes from within the planet, where chemistry becomes dynamic. And if something similar exists on Europa, then tidal heating is not just keeping water liquid, it is powering a system that may be capable of supporting something more. But we must be careful, because energy alone does not create life. It only creates possibility. And Europa is full of possibility, because it has heat, it has water, and it has interaction between its layers. But there is still one question, a critical one. How stable is this heat? How long can it last? Because if tidal heating were temporary, then the ocean would eventually freeze, the system would shut down, and everything would become still. But the evidence suggests otherwise, because Europa has remained active for a very long time, which means this process is stable, sustained, continuous. And that stability is what makes it so important, because long-lasting systems have time to evolve, time to develop complexity, time for processes to go further. And that brings us closer to something deeper, something more significant. Because when we combine everything we know, the surface activity, the hidden ocean, the internal heat, we begin to see a pattern. Europa is not just a frozen moon with a hidden ocean. It is a system, a connected system, where energy flows, where materials interact, where change is constant. And systems like that are rare, because most worlds are simple, static, inactive. But Europa is not. It is active, from the inside out, driven by forces that should not be enough, but somehow are. And that is what makes it strange, not just because it has an ocean, but because it has the energy to sustain it. An energy source, hidden from view, silent, invisible, but powerful enough to change everything. And somewhere beneath that ice, in that dark ocean, that heat continues to move, to circulate, to shape a world we have not yet seen. A world that exists because of a force we cannot feel, but cannot escape. Gravity, relentless, unseen, and powerful enough to keep an ocean alive in the coldest depths of space. There is something unusual about Europa's surface, something that becomes clearer the longer you look at it. It is not just fractured, it is rearranged. On most worlds, when a surface breaks, it stays broken. The marks remain, the damage accumulates. Over time, the landscape becomes a record of everything that has happened. But Europa does something different. It resets. The cracks do not simply form and remain, They evolve, shift, disappear, and then reappear again in new forms. And this constant cycle of breaking and rebuilding is what makes Europa so difficult to understand, because the surface you see today is not the original surface. It is only the latest version. Some of the most striking regions on Europa are known as chaos terrain, and they look exactly like their name suggests. Instead of smooth ice or long continuous cracks, these regions are broken into blocks, large sections of crust separated from each other, tilted, rotated, moved out of place. It looks as if the surface has been shattered completely and then partially put back together, but not carefully, not precisely, just enough to form something stable again. These blocks are not small. Some are kilometers across, entire sections of the crust, floating like pieces of ice on a frozen ocean. And that comparison is not just visual, it may be literal, because the only way for such large pieces to move is if they are not anchored, if they are floating, which suggests something extraordinary. That in these regions, the ice crust may be thin enough to break apart completely and drift on top of liquid water below. But the process does not end there, because after the movement, after the shifting, the surface stabilizes again, the gaps freeze, the blocks become locked in place, and a new landscape is formed, until it happens again. This cycle of destruction and reconstruction is not random. It is driven by the same forces we have already seen: tidal stress, internal heat, interaction with the ocean below. But chaos terrain is only one part of the story, because even outside these regions, Europa's surface is changing. Some areas show evidence of spreading, where the ice has pulled apart, creating new space between sections. And then, that space has been filled, not by external material, but by ice rising from below. Fresh ice, warmer, softer, pushed upward, and then frozen again. This process is similar to what happens on Earth's ocean floors, where new crust forms as material rises from below. But on Europa, it is ice, not rock, and the process is slower, more subtle, but still active. Other regions show the opposite: compression, where the surface has been pushed together, creating ridges, folds, overlapping layers of ice. And when you look at the surface as a whole, you begin to see a pattern, not chaos, not randomness, but a system. A system where ice behaves almost like a fluid, slowly, over long periods of time, responding to forces, adapting, changing shape. And this is where Europa becomes even more unusual, because ice, in the conditions we understand, is rigid, solid, unchanging. But under pressure and over time, it behaves differently. It flows, very slowly, almost imperceptibly, but enough to reshape entire landscapes. And that flow, combined with the ocean below, creates a dynamic surface, a surface that is not fixed, not permanent, but evolving. There is another feature that reveals this process even more clearly: linear ridges. These ridges are long, parallel, sometimes double or triple in structure, running across the surface for vast distances. They are not random fractures. They are constructed, built over time. As cracks open, material from below is pushed upward, freezes, expands, and forms raised edges, Then the crack closes, and the process repeats again and again, layer upon layer. Over time, these ridges grow, becoming more pronounced, more complex. And when you trace their paths, you begin to see how widespread this activity is. Because these ridges are everywhere, crossing the surface in every direction. A network of structures formed by repeated cycles of opening and closing. And this tells us something important. The surface of Europa is not passive, it is responsive. It reacts to forces, it adapts to stress, it changes in response to what is happening below. But there is still something missing. Because while we can see how the surface changes, we do not yet fully understand how deep these changes go. How thick is the ice? How far do these cracks extend? Do they reach the ocean below, or do they stop somewhere in between? Because if even a small number of cracks connect directly to the ocean, then Europa is not sealed. It is open, at least partially. And that would mean material from the ocean can reach the surface, and material from the surface can move downward. A two-way exchange. And that possibility is one of the most important in all of planetary science, because it means the hidden ocean is not completely isolated. It interacts, it communicates, it influences the surface above. And that interaction could carry information, chemicals, energy, everything needed to transform a simple ocean into something more complex. But even without that connection, Europa's surface tells us something profound. That this is not a dead world, not a frozen shell. It is active, dynamic, alive in its own way, even if not biologically. A world where ice moves, where landscapes rebuild themselves, where nothing remains unchanged for long. And as we continue to study it, to map its surface, to analyze its patterns, we begin to understand something simple. Europa is not what it appears to be. Because what looks like a frozen crust is actually a thin, fragile layer floating above something far more powerful. And every crack, every ridge, every broken piece of terrain is a reminder that beneath that ice, something is still moving, still shaping the world above. A hidden force, slowly rewriting the surface, one fracture at a time. If Europa were only ice, it would be a curiosity, a strange world, fractured, active, but ultimately simple. But it is not just ice. It is ice covering an ocean, and that changes everything. Because an ocean is not just water. It is an environment, a place where interactions happen, where energy flows, where chemistry evolves, and where, under the right conditions, something more can begin. On Earth, life is everywhere there is water, from the surface to the deepest parts of the oceans, even in places where sunlight never reaches, even in environments once thought to be completely inhospitable. Deep beneath Earth's oceans, there are regions of total darkness, no light, no warmth from the sun, no connection to the surface world. And yet, life exists there. At the bottom of the ocean, there are hydrothermal vents, cracks in the seafloor, where heat from the planet's interior escapes into the water. These vents release energy, chemicals, heat. And around them, life forms, not based on sunlight, but on chemistry. Organisms that draw energy from reactions between water and rock, from the movement of heat, from the mixing of materials. This discovery changed everything because it proved something fundamental. Life does not require sunlight, it requires energy. And Europa has energy. Beneath its surface, tidal heating continues. The interior remains warm, the ocean remains liquid. And if the rocky core below interacts with that ocean, then similar processes could exist. Water meeting rock, heat rising from below, chemical reactions occurring in the dark. A system not unlike the deep oceans of Earth, but colder, slower, more extreme. And that is where the possibility begins. Not as certainty, not as proof, but as a question. Could Europa's ocean support life? At first, the idea seems distant, speculative, almost impossible to confirm. Because we have not seen it, we have not reached it. But when we look at what is required, the pieces begin to align. Water, Europa has it, in vast quantities, more than Earth. Energy, Europa has that too, from tidal heating, sustained, continuous. Chemistry, likely present, as water interacts with the rocky interior, as materials move between layers, as compounds dissolve and react. Three fundamental components, all present, all active, all interacting. And that combination is rare, because most worlds have only one or two. Few have all three. And Europa may be one of them. But there are challenges, serious ones, because Europa is not Earth. Its ocean is sealed, covered by kilometers of ice, cut off from sunlight, isolated from the surface. Which means any potential life would exist in complete darkness, under immense pressure, in conditions far more extreme than most environments on Earth. And yet, we already know that life on Earth can survive in extreme conditions. In freezing temperatures, in high pressure, in complete darkness, in environments filled with chemicals that would be toxic to most organisms. So the question is not whether life can exist in extreme conditions. It already does. The question is whether those conditions exist on Europa in the right way. Because life is not just about survival. It is about emergence, about origin, about the process that transforms chemistry into biology. And that process is still not fully understood, even on Earth. We know it happened, but we do not know exactly how or under what precise conditions, which makes Europa even more important, because it may represent a different path, a different environment, a different starting point, a place where similar processes could occur in a completely different setting. But there is another possibility, one that is even more difficult to consider. That life on Europa, if it exists, may not resemble life on Earth at all. Because everything we know about life comes from a single example, one planet, one system. And Europa is not that system. Its chemistry may be different, its energy sources may vary, its environment is colder, darker, more isolated. Which means, if life exists there, it may be unfamiliar, difficult to recognize, perhaps even invisible to the methods we currently use. And that is what makes the search so complex. because we are not just looking for what we know, we are looking for what we do not yet understand. Patterns that may not be obvious, signals that may not be clear, evidence that may not look like evidence. And yet, the possibility remains. Because Europa has something rare, something valuable, something that few places in the solar system possess. A stable, long-lasting environment. Its ocean has likely existed for billions of years, sustained by tidal heating, protected by ice, shielded from radiation. And time is critical, because complex processes require time. Time for interactions, time for chemistry, time for systems to evolve. And Europa has had that time, which means if something were to begin, it would have had the opportunity to continue, to develop, to persist. But we do not know. Not yet, because the ocean remains hidden, sealed beneath ice, out of reach. And until we find a way to access it, to sample it, to observe it directly, the question will remain unanswered. But even without that answer, Europa has already changed how we think, because it shows us that habitable environments are not limited to planets like Earth. They can exist beneath surfaces, hidden, protected, in places we once believed to be completely lifeless. And that realization expands the search far beyond what we once imagined. Because now, we are not just looking for Earth-like worlds. We are looking for oceans, hidden oceans, dark oceans, worlds beneath the surface. And Europa is one of the most compelling of them all. A place where the conditions are right, where the system is active, where the possibility exists, not as certainty, not as proof, but as something far more powerful. A question. And somewhere, beneath that frozen crust, in a vast, silent ocean, that question remains, waiting for an answer. Knowing something exists is not the same as reaching it. Europa has already revealed its secret. An ocean, hidden beneath ice. A place that may hold answers to one of the oldest questions we have ever asked. But knowing it is there is only the beginning. Because between us and that ocean, there is a barrier, a thick, frozen shell, kilometers deep, cold, hard, and constantly shifting. On Earth, we drill through ice. We reach beneath glaciers. We explore environments once thought inaccessible. But Europa is not Earth. It orbits Jupiter, a world surrounded by intense radiation, a region of space that is far more hostile than anything we experience on our planet. Any spacecraft sent to Europa must survive that environment. Electronics exposed to radiation, materials slowly degrading, systems pushed to their limits. And that is only the first challenge. Because even if we reach the surface, we are still far from the ocean. The ice shell of Europa is not a thin layer. It may be several kilometers thick, possibly tens of kilometers in some regions. And this ice is not uniform. It is fractured, layered, mixed with different materials. Which means drilling through it is not simple. It is not predictable. On Earth, we can plan, we can adapt, we can respond in real time. But on Europa, everything must be done remotely, from millions of kilometers away, with delays in communication, with no direct control. which means any system designed to reach the ocean must operate on its own, autonomous, reliable, capable of handling conditions we cannot fully predict. One concept often discussed is a cryobot, a probe designed to melt its way through the ice. Instead of drilling, it uses heat, slowly melting the ice beneath it, descending deeper, meter by meter, carrying instruments, sensors, possibly even a second probe, to explore the ocean once it is reached. But this idea comes with challenges. How do you power such a system? How do you generate enough heat to melt through kilometers of ice? How do you prevent the tunnel behind it from refreezing? And perhaps most importantly, how do you communicate with something buried so deep? Signals cannot easily pass through ice, especially thick, dense ice, which means the probe must remain connected to the surface through a cable, a link, a fragile connection that must survive the entire journey. And that journey could take weeks, months, possibly longer. All the while, the environment around it remains unknown. The ice may not be solid all the way through. There may be pockets, channels, regions of softer material, or areas where the ice becomes harder, more difficult to melt, more resistant to movement. And each variation adds uncertainty. But even if we solve these problems, even if we reach the ocean, there is another challenge waiting. What do we do next? Because entering Europa's ocean is not like entering an ocean on Earth. There is no light, no reference points, no clear sense of direction. A probe entering that ocean would descend into total darkness, guided only by its instruments, its programming, its ability to interpret an environment we have never seen. And the ocean itself may not be calm. Currents could exist, driven by heat, by rotation, by interactions with the ice above and the core below. Temperatures may vary, chemistry may change, conditions may shift from one region to another. And within that environment, we would be searching, not just for data, but for signs, patterns, evidence of something more. But there is another concern, one that is often overlooked: contamination. Because when we send a probe to a place like Europa, we do not go alone. We carry with us traces of Earth, microorganisms, particles, materials that could survive the journey. And if we are not careful, we risk introducing those materials into an environment that has remained isolated for billions of years, which means any mission to Europa must be extremely clean, sterilized, controlled, designed to prevent any form of contamination. Because if life exists there, we must not disturb it. And if it does not exist, we must not introduce it. This is not just exploration, it is responsibility. A balance between curiosity and caution. But despite all these challenges, the effort continues. Because Europa is too important to ignore. It represents something rare, a place where the conditions for something extraordinary may exist. And as technology advances, as our understanding improves, we move closer, closer to landing, closer to exploring, closer to reaching what lies beneath. Missions are already planned, orbiters, landers, instruments designed to study the surface in detail, to analyze the ice, to search for signs of interaction between the surface and the ocean. Each mission, a step forward. Each discovery, bringing us closer to the moment we have been waiting for. The moment when we no longer infer, but observe. When we no longer imagine, but see. Because Europa's ocean is not just a scientific question. It is a destination. A place that exists right now, hidden beneath ice, waiting to be reached. And when that moment comes, when we finally break through, when we enter that dark, silent world, we may find nothing. Or we may find something that changes everything. And that is why we continue. Not because it is easy, not because it is certain, but because it is possible. And sometimes, possibility is enough. For a long time, Europa kept its distance. We could see its surface. We could study its cracks. We could analyze its structure. But everything we believed about it came from interpretation, from indirect evidence, from patterns that suggested something more, but never confirmed it. The ocean was a theory, a strong one, supported by physics, by observation, by logic, but still a theory, because we had never seen it, never touched it, never detected anything that came directly from below the surface. And then something changed. It did not come from a landing, not from drilling, not from reaching the ocean itself. It came from space, from observation, from a subtle but powerful signal. A plume, a faint column of material rising from Europa's surface, not ice alone, not dust, but something more. Water vapor. For the first time, there was evidence that material from beneath the surface was escaping into space. The discovery was not immediate. It was not obvious. It came from careful observation, from instruments designed to detect faint changes in light, from the way Europa interacted with its environment. And what those instruments revealed was extraordinary. Columns of vapor, rising hundreds of kilometers above the surface, thin, faint, but real. And that changed everything. Because if material is escaping from Europa, then the surface is not sealed. There are openings, pathways, connections between the ocean below and the space above. And that means Europa is not just hiding an ocean, it is releasing it. But how? The surface is cold, rigid, frozen. So how does water, liquid water, reach the surface? The answer lies in pressure. Beneath the ice, the ocean is not static. It is active, moving, circulating. And as heat builds in certain regions, as tidal forces continue to flex the moon, pressure increases. In weak points, in fractures, in areas where the ice is thinner, that pressure finds a way out. And when it does, it escapes. Water rises rapidly. But as it approaches the surface, it encounters extreme cold. It does not remain liquid. It freezes, vaporizes, expands. And what emerges is a plume, a jet of material bursting into space. Not continuously, not constantly, but in moments, events, short-lived releases of what lies beneath. And each plume is a message, a signal from the ocean below. because it carries material, particles, compounds, information. Everything that exists in that hidden ocean has the potential to be brought to the surface. And for the first time, we do not need to drill. We do not need to break through the ice, because Europa is doing it for us. It is offering a way to study its ocean without reaching it directly. A way to analyze what lies beneath, from above, by passing through those plumes, collecting samples, studying their composition. And that possibility is one of the most exciting in all of space exploration, because it simplifies something that once seemed impossible. Instead of drilling kilometers of ice, we can intercept a plume. Instead of guessing what lies below, we can analyze it directly. And that changes the approach, the strategy, the future of exploration. But the plumes themselves raise new questions. How often do they occur? Where do they originate? How deep do they connect? Because not all fractures are the same. Some may reach deep, connecting directly to the ocean. Others may only access pockets, reservoirs within the ice. It's temporary stores of liquid water trapped between layers. And distinguishing between these possibilities is critical, because only some plumes may carry material from the ocean itself, and identifying those plumes becomes the key. But even with uncertainty, the significance remains. Europa is not closed. It is active, open, dynamic. A world where the boundary between inside and outside is not absolute, where the hidden ocean can reach the surface, even if only briefly. And that changes how we see it. Because before, Europa was a mystery. Now, it is a system that reveals itself. Not completely, not clearly, but enough to show us that what lies beneath is not isolated. It interacts, it escapes, it becomes visible. And that visibility brings us closer than ever before. Closer to understanding, closer to discovery, closer to answering the question that has been building since we first realized what Europa might be. Is there something there? Something more than water, more than chemistry, more than a system. Something alive. Because if the ocean communicates with the surface, if material rises and escapes, then traces, however small, may be detectable. And that possibility is what drives the next step. To follow those plumes, to study them, to understand what they carry. Because within them may be the first real clues, not hidden beneath kilometers of ice, but released into space, waiting to be found. And as Europa continues to orbit Jupiter, those plumes may rise again. Silent, brief, easy to miss, but powerful enough to change everything we thought we knew. Because sometimes, a single moment, a single event, is enough to reveal what has been hidden all along. And Europa has already begun to reveal itself. For decades, Europa has remained just out of reach, close enough to study, close enough to understand in part, but never close enough to truly explore. We have seen its surface, mapped its cracks, detected signs of an ocean, even observed plumes rising into space. But all of this has been done from a distance, from orbit, from flybys, from brief encounters with a world that hides its secrets well. And now, that is about to change. Because Europa is no longer just a target of curiosity, it is a destination, a place we are preparing to return to, not just to observe, but to investigate. The next step in that journey is already in motion, a mission designed specifically for Europa. The Europa Clipper, a spacecraft built with one purpose: to understand Europa's habitability, not to land, not to drill, but to study, in detail, with precision, with instruments far more advanced than anything that came before. Instead of orbiting Europa directly, it will orbit Jupiter, passing close to Europa again and again. Dozens of flybys, each one collecting data, mapping the surface, analyzing the ice, measuring the thickness of the crust, using radar to look beneath the surface, not to reach the ocean, but to understand the layers above it, to detect pockets of water, regions where the ice is thinner, areas where interaction between surface and ocean may be strongest, because those areas are the key. If we want to understand Europa, we need to find the places where it reveals itself most clearly, where the ice is weakest, where the ocean is closest, where the connection is strongest. And Europa Clipper is designed to do exactly that. It will also study the plumes, if they appear, if they rise again. It will pass through them, analyze their composition, search for molecules, compounds, signs of chemistry that could hint at something more. And for the first time, we may have direct evidence, not from theory, not from interpretation, but from material that came from the ocean itself. But Europa Clipper is only the beginning. Because once we understand the surface, once we identify the most promising regions, the next step becomes possible. Landing. A Europa lander has been proposed, a mission that would touch down on the icy surface, remain there, study the environment directly, analyzing the ice, the chemistry, the structure, looking for signs of interaction with the ocean below. Even without drilling, a lander could reveal a great deal. Because if material from the ocean reaches the surface, even in small amounts, it may leave traces, frozen into the ice, carried upward through cracks, deposited over time. And those traces could be studied. But landing on Europa is not simple. The surface is unknown, uneven, possibly unstable. And the radiation environment remains a major challenge. Any lander must survive long enough to collect meaningful data. Days, weeks, possibly longer. Operating in conditions that push technology to its limits. But beyond landing, there is something even more ambitious. Something that has never been done before. Reaching the ocean. Not just observing it, not just sampling plumes, but entering it. The idea remains theoretical, for now. A probe that could penetrate the ice, descend through kilometers of frozen crust, and release a second explorer into the ocean below. A submersible, a machine capable of navigating a world of total darkness. Searching, scanning, exploring an environment that has never been seen. And while this idea may still be years away, it is no longer impossible. Because each mission, each discovery brings us closer to understanding how to overcome the challenges, closer to developing the technology, closer to making it real. But even before we reach that point, Europa Clipper will change everything, because it will answer questions we have been asking for decades. How thick is the ice? Where are the most active regions? How does the ocean interact with the surface? What is the composition of the plumes? And perhaps most importantly, what is Europa capable of? Because before we search for life, we must understand the environment. We must know if the conditions are right, if the system is stable, if the necessary elements are present. And that is what this mission will do. It will not give us all the answers, but it will give us direction, a clearer path forward, a better understanding of where to look and how to look. Because exploration is not a single step. It is a process, a sequence of missions, each building on the last, each bringing us closer. And Europa is now part of that journey. No longer just a distant moon, no longer just a mystery, but a place we are actively preparing to explore. And as we move forward, as we send these missions, as we gather more data, we come closer to something profound, the possibility of discovering something new, not just about Europa, but about the universe. Because if Europa's ocean can support life, then similar worlds may exist everywhere, hidden beneath ice, beyond the reach of sunlight, waiting to be discovered. And that means the search is no longer limited. It expands beyond planets, beyond what we once considered habitable, into places like Europa. And as we prepare to return, to study, to explore, we are not just visiting a moon. We are stepping closer to one of the most important discoveries we may ever make. A discovery that could change how we see life forever. There is something deeply unsettling about the idea of Europa, not because it is distant, not because it is cold, but because it should not exist the way it does. A moon covered in ice, orbiting far from the sun, should be simple, frozen, inactive, silent. That is what we expected. That is what we found on so many other worlds. But Europa refused to follow that pattern. Instead of stillness, there is motion. Instead of silence, there is activity. Instead of emptiness, there is an ocean. And not just any ocean, a global ocean, hidden beneath ice, maintained by a source of heat that should not be strong enough, and yet is. And that contradiction is what makes Europa so important. Because it forces us to question something fundamental. What makes a world capable of supporting life? For a long time, we believed the answer was simple. Distance from a star, surface temperature, liquid water on the surface, conditions like Earth. But Europa does not meet those conditions. It is too far from the sun, too cold. Its water is not on the surface, but hidden beneath kilometers of ice. And yet, it has the three things we keep returning to: water, energy, chemistry. Not in the way we expected, but in a different form. And that difference changes everything, because it suggests that habitability is not limited to Earth-like planets. It can exist in places we once ignored. Hidden environments, subsurface oceans, worlds that appear lifeless from the outside but are active within. And if that is true, then Europa is not unique. It is part of a larger pattern. Other moons may have similar oceans, similar conditions, similar potential. And suddenly, the number of possible habitats in the solar system increases dramatically, because we are no longer limited to surfaces. We are looking beneath them. But there is something else, something deeper, because Europa does not just expand where we search for life. It changes how we define it. Because everything we know about life comes from Earth, from one example, one system, one set of conditions. And we have built our understanding around that example. But Europa challenges that. Because if life exists there, it would not rely on sunlight. It would not follow the same rules. It wouldn't be visible in the ways we expect. It would exist in darkness, driven by chemistry, sustained by energy from within the moon itself. And that means life may not be rare. It may simply be different. But there is a tension in that idea, a balance between possibility and uncertainty. Because while Europa has the ingredients, we do not know if it has the outcome. We do not know if chemistry has gone far enough, if complexity has reached the point where life can emerge. And that uncertainty is what keeps the mystery alive. Because Europa sits on the edge, between what we know and what we do not, between what is possible and what has not yet been proven. A world that has gone far, but not far enough for us to be certain. And that almost is what makes it so compelling. Because it is close, close to being something more, close to crossing a boundary we do not fully understand. And that boundary is the most important one of all. The transition from chemistry to life. We know it happened on Earth, but we do not know exactly how. And Europa may hold clues. Because it exists in a different environment, a different pathway, a different set of conditions. And by studying it, we may learn something new. Not just about Europa, but about the process itself. How life begins. Whether it requires specific conditions, or whether it can emerge in many different environments. Whether Earth is special, or simply one example of something that happens more often than we think. And that is where Europa becomes more than a moon. It becomes a test, a way to challenge our assumptions, to expand our understanding, to explore possibilities we once ignored. But there is also something else, something quieter. Because when we imagine Europa, we often focus on the science, the data, the measurements. But beneath all of that, there is something more human. Curiosity, the desire to know what lies beneath, to understand what is hidden, to explore what we cannot see. Europa represents that desire. A world we cannot access, but cannot ignore. A place that invites us to look deeper, to go further, to ask questions that do not yet have answers. And that is what makes it so powerful, because it reminds us that the universe is not fully known, that there are still places that challenge us, still mysteries waiting to be explored. And Europa is one of the closest, not in distance, but in possibility. A world that exists just beyond our reach, but not beyond our understanding. A world that should not be possible, and yet is. And as we continue to study it, to prepare missions, to develop the technology to explore it more deeply, we move closer to answers, closer to discovery, closer to a moment that could change everything. Because if Europa's ocean holds even the simplest form of life, then life is not unique to Earth. It is part of the universe. And that realization would reshape everything we believe. But even if it does not, even if Europa's ocean remains lifeless, it still matters. Because it shows us how far a world can go, how complex a system can become, without crossing that final threshold. And that knowledge is just as important, because it helps us understand the boundary itself, where it lies, what it requires, how it can be crossed. And that is why Europa continues to matter. Not because it gives us answers, but because it gives us questions. And sometimes, the right question is more powerful than any answer, because it leads us forward into the unknown, into places we have not yet explored, into possibilities we have not yet imagined. And somewhere, beneath that frozen surface, in a vast, silent ocean, that possibility remains, waiting, not to be imagined, but to be discovered. And yet, even after everything we have considered, Europa still holds something back, because knowing the conditions is not the same as understanding the outcome. We can map the surface, we can model the ocean, we can calculate the heat. But there is a gap between what is possible and what is real. And that gap is where the deepest mystery exists. Because inside Europa's ocean, if it exists as we believe, there are no observers, no light, no reference. Only motion, only interaction, only time. Time stretching across millions of years, across billions of years. And in that time, something could happen. Not suddenly, not dramatically, but slowly. Molecules forming, breaking apart, reforming again. Structures becoming more stable, more complex. Patterns emerging, not by design, but by interaction. Because complexity does not require intention, it only requires conditions. And Europa has those conditions. A constant source of energy, a stable environment, a vast ocean, protected from the chaos of space. And protection matters. Because while the surface of Europa is exposed to radiation, to extreme conditions, the ocean below is shielded. The ice above acts as a barrier, a layer of protection, blocking harmful radiation, maintaining stability, preserving the environment below. And that stability is rare, because most environments in space are unstable. Too hot, too cold, too exposed, too violent. But Europa's ocean is different. It is isolated, contained. a world within a world. And in that isolation, processes can continue uninterrupted. No sudden changes, no external disruptions. Only slow, continuous evolution. And that is exactly the kind of environment where complexity can grow. But there is something else, something even more subtle. Because Europa's ocean is not just stable, it is connected. Connected to the core below, connected to the ice above. Energy flows upward, materials move between layers. And that movement creates gradients, differences in temperature, in chemistry, in energy. And where differences exist, interaction follows. Because systems do not remain balanced on their own. They respond, they adjust, they evolve. And over time, those interactions can lead to something unexpected. Not necessarily life, but something approaching it. Because the line between chemistry and life is not sharp. It is gradual, a progression from simple interactions to complex systems, from randomness to structure. And somewhere along that path, a threshold is crossed. But we do not know where that threshold lies. We do not know what conditions are required. And that is why Europa matters. Because it may exist very close to that boundary. Close enough to help us understand it. Close enough to reveal how far complexity can go without becoming something more. Or perhaps close enough to show us that it already has. And that is the possibility that changes everything. Because if life exists on Europa, it would not be a coincidence. It would mean that life can emerge in more than one way, in more than one environment, that it is not limited to planets like Earth, but can exist in hidden oceans, beneath ice, far from the sun. And that would transform our understanding of the universe, because it would mean that life is not rare. It is possible. And if it is possible here, it may be possible elsewhere, on other icy moons, on distant worlds, in environments we have not yet explored. But even if Europa is empty, even if its ocean holds no life, it still tells us something profound. It shows us how far a system can go, how complex it can become, how close it can get to something more, without crossing that final boundary. And that knowledge is just as important, because it helps us define that boundary, to understand what separates the living from the non-living, to identify the conditions that allow that transition to occur. And that understanding is one of the most important goals in all of science, because it is not just about Europa. It is about us, about how life began on Earth, about how it may begin elsewhere, about whether we are unique or part of something larger. And as we continue to study Europa, to prepare missions, to refine our models, we move closer to answering those questions. Not all at once, not immediately, but step by step, discovery by discovery, until one day we may reach that ocean. We may see it, not as an idea, not as a theory, but as a real place, a dark, vast world, hidden beneath ice. And in that moment, everything we have imagined everything we have calculated, everything we have hoped for, will be tested, and whatever we find there, whether it is empty or filled with something we do not yet understand, it will change us, because Europa is not just a destination. It is a question that has been waiting beneath ice in silence for billions of years, and we are only now beginning to listen. There is a moment in every exploration when the questions begin to change. At first, we ask what something is. Then, we ask how it works. But eventually, we begin to ask something deeper. What does it mean? Europa has taken us through all of that, from a distant point of light to a world of fractures and motion, to an ocean hidden beneath ice. We have followed the evidence, measured the heat, mapped the cracks, imagined the ocean. And now, we arrive at the final question. Not just what Europa is, but what it represents. Because Europa is not simply a moon. It is a threshold, a place where two ideas meet. The idea that life is rare, and the idea that life is everywhere. And somewhere beneath that ice, the answer may already exist. But there is something strange about that thought, because even now, even with all we know, Europa remains silent. No signals, no movement we can directly observe, no confirmation. Only indirect evidence, clues, patterns, possibilities. And yet, that silence does not feel empty. It feels full of potential, full of something waiting. Because silence, in a place like Europa, is not the absence of activity. It is the absence of observation. We are not hearing nothing. We are simply not yet able to listen. And that distinction matters, because it reminds us that the universe does not reveal itself easily. It does not offer answers without effort. It requires patience, precision, time. And Europa demands all three. We cannot rush this. We cannot assume. We must explore, carefully, deliberately, because what we may find there could change everything. But even if it does not, even if Europa remains silent, it still changes something. It changes us, because it forces us to expand our perspective, to consider that life may not look like what we expect, that it may exist in darkness, in isolation, in environments we once dismissed. And that realization is powerful, because it shifts the way we look at the universe. We stop searching only for worlds like Earth. We begin searching for conditions, for systems, for possibilities. And suddenly, the universe becomes larger, not in size, but in meaning. Because more places become relevant, more worlds become important. And Europa stands at the center of that shift, a world that redefines what we consider possible. But there is also something else, something quieter. Because beyond the science, beyond the missions, beyond the data, Europa represents something deeply human. The desire to go further, to understand more, to reach beyond what is known. It is the same instinct that led us to explore our own oceans, to dive into depths we could not see, to map territories we did not understand. And now we are doing the same thing on a cosmic scale, preparing to explore an ocean that is not on Earth, an ocean that has never seen light. And that idea is both exciting and humbling, because it reminds us how small we are, how little we have seen, how much remains unknown. But it also reminds us how far we have come, from looking at the sky to sending machines across the solar system, from wondering to preparing to explore. And Europa is part of that journey, not the end, not the final destination, but a step toward understanding the deeper nature of life. And as we stand on that step, looking forward, there is a sense of anticipation, because we know what comes next. More missions, more data, more exploration, and eventually a closer look. Perhaps one day a probe will reach the ocean. Perhaps one day we will see it directly. And in that moment, everything changes, because we will no longer be imagining. We will be observing. We will no longer be asking if it exists. We will be asking what it is and what it means. But until that moment arrives, Europa remains what it has always been: a mystery, a silent world, hiding something beneath its surface. Something that may be simple or complex, empty or alive. We do not know. And that is what makes it powerful, because the unknown is what drives exploration. It is what pushes us forward, what forces us to ask questions, to seek answers. And Europa is one of the greatest unknowns we have ever encountered. Not because it is far away, but because it is close enough to matter. Close enough to challenge us. Close enough to change everything. And somewhere beneath that frozen shell, in a vast, dark ocean, the answer is waiting. Not calling out, not revealing itself, but existing quietly until the moment we finally arrive. Part 10, Extended. What waits when we finally look? And even after everything we've imagined, everything we've calculated, everything we've prepared for, Europa remains just beyond that final step. Because there is a difference between knowing something exists and standing in front of it. We know the ocean is there. We know the ice is thick. We know energy moves through the system. But we have never seen it. Not directly. No camera has entered that ocean. No light has ever reached its depths. And that absence creates something powerful. Because when we cannot see, we begin to imagine. We imagine vast, dark waters stretching endlessly beneath the ice. We imagine slow currents moving through a silent world. We imagine chemical reactions happening in complete darkness. And then we imagine something more. Something moving, not fast, not dramatic, but present. And that is where imagination becomes dangerous and necessary at the same time. Because we must be careful. We must not assume life exists. We must not force meaning where there may be none. But we also cannot ignore what the conditions allow. Because if Europa teaches us anything, It is that the universe does not follow our expectations. It creates environments that seem impossible until we understand them. And sometimes, those environments are more capable than we ever imagined. So we stand in a strange position, between restraint and curiosity, between caution and wonder. And that balance is what defines exploration, because we are not just searching for answers. We are preparing ourselves to accept them, whatever they may be. If Europa is empty, then we learn something important. We learn that even with water, energy, and time, life may not always emerge. That there are limits, conditions we do not yet understand, barriers we cannot yet see. And that knowledge will refine our search. It will make us more precise, more careful, more aware. But if Europa is not empty, if even the simplest form of life exists, then everything changes. Because it means life is not an exception. It is a process, a natural outcome under the right conditions. And those conditions may exist far more often than we thought. In hidden oceans, in distant systems, in places we have not yet reached. And suddenly, the universe is no longer silent. It is full. Not necessarily with intelligence, not necessarily with complexity, but with possibility. And that realization would be one of the most profound in human history, because it would answer a question we have been asking for as long as we have looked at the sky. Are we alone? Europa may not give us a complete answer, but it may give us the first indication that the answer is no. And even that would be enough. Enough to change how we see ourselves, enough to change how we see the universe. But there is one more layer to this, something deeper than science. Because Europa is not just about discovery. It is about perspective. It reminds us that the universe is not designed to be easily understood, that its most important secrets are often hidden, beneath surfaces, behind barriers, inside systems that require effort to explore. And that effort is part of the meaning. Because exploration is not just about reaching a place. It is about becoming capable of reaching it, developing the tools, the knowledge, the patience. And Europa demands all of that. It forces us to evolve, to think differently, to build differently, to explore differently. And in doing so, it changes us. Because every step we take toward Europa is also a step forward for us, in understanding, in capability, in perspective. And that is why this journey matters, even before we arrive. Because by the time we reach that ocean, we will not be the same. We will be ready. Ready to see what is there. Ready to understand it. Ready to accept what it means. And maybe that is the most important part. Because discovery is not just about finding something new. It is about being prepared to understand it. And as we look at Europa now, as a distant, silent world, we are still preparing, still learning, still building, still moving closer, closer to that moment. The moment when the ice is no longer a barrier, when the ocean is no longer hidden, when the silence is finally broken, not by sound, but by understanding. And when that moment comes, whatever we find, whatever waits beneath that ice, it will not just belong to Europa, it will belong to all of us, because it will answer something deeper than a scientific question. It will answer something human, a question we have carried across generations, across cultures, across time. And somewhere, in the darkness beneath that frozen shell, that answer already exists, waiting, not to be imagined, not to be guessed, but to be seen for the first time. There comes a point in every journey of discovery when the search itself begins to change. At the beginning, we were looking outward, searching for distant stars, distant planets, distant signals. We believed the answers would be far away, hidden across light years of space. But Europa, quietly, almost silently, changed that idea, because it showed us something unexpected, that the answers we are searching for might not be distant at all. They might be closer, hidden, just beneath the surface of a frozen world orbiting a giant planet. And that realization is more powerful than it first appears, because it shifts the entire direction of exploration. We stop asking only, where is life out there? And we begin asking, where is life hidden? Right here, within our own solar system, within places we once ignored. Europa is one of those places. At first glance, it looks simple, a frozen sphere, covered in ice, silent. But we now know that silence is deceptive, because beneath that surface, there is motion, energy, interaction, a system that should not exist, and yet does. And as we've moved through this journey, we've uncovered the pieces. The cracked surface, constantly reshaped, the tidal forces driving internal heat, the hidden ocean, vast and deep, the chemistry, rich with possibility. Each piece on its own is not enough, but together they form something extraordinary, a world that is not dead, not frozen in time, but active, dynamic, a system that continues to evolve even now. And that brings us here, to the edge of the unknown, because everything we've learned leads to one final possibility. Not certainty, not proof, but possibility, that beneath the ice of Europa, something may exist. Not something large, not something visible, but something small, simple. Something that does not need light, does not need warmth. Only stability, energy, time. And Europa has all three. Time, stretching across billions of years. Energy, rising from its interior. Stability, protected beneath thick ice. And when those conditions exist, something can happen. Not suddenly, not dramatically, but gradually. Chemistry becomes more organized, structures begin to form, systems become more stable. And eventually, something crosses a threshold. From non-living to living. We do not know exactly how that happens. Even on Earth, the origin of life remains a mystery. But Europa gives us another place to look, another example, another chance to understand that transition. And that is why it matters. Because if life exists on Europa, then life is not unique. It is not rare. It is a natural outcome. And that changes everything. It means the universe is not empty. It is filled with potential, filled with environments where life can emerge, hidden worlds, dark oceans, distant systems. And suddenly, the question is no longer, is there life elsewhere? It becomes, how much life is there? But even if Europa is silent, even if its ocean holds nothing, it still changes our understanding, because it shows us how close a world can come, how far chemistry can evolve without crossing that final boundary. And that knowledge is just as important, because it tells us where the limits are, where possibility ends and reality begins. But there is something deeper, something beyond science. Because Europa is not just about life. It is about perspective. For most of human history, we believed we were central, that everything revolved around us. But discovery after discovery has shown us otherwise. We are not at the center. We are not unique in location. And Europa challenges us again, not by proving we are not alone, but by suggesting we might not be. And that suggestion is enough to shift everything, because it changes how we see ourselves, not as the only example of life, but as one possibility among many. And that idea is both humbling and powerful, because it connects us to something larger, to a universe that is active, dynamic, full of processes that continue whether we observe them or not. And somewhere within that universe, beneath layers of ice, in complete darkness, those processes may have gone further than we have seen before, further than we have confirmed. And that is what we are moving toward. Not just knowledge, but understanding, because there is a difference. Knowledge tells us what is there. Understanding tells us what it means. And Europa is not just something to be known. It is something to be understood, because it represents a turning point, a shift in how we explore, how we think, how we search. We are no longer limited to surfaces. We look beneath them. We no longer search only for light. We search in darkness. We no longer define habitability by distance from a star. We define it by systems, by energy, by chemistry, by time. And that change is one of the most important in modern science, because it expands our reach. It tells us that life may exist in places we never considered. And that means the search is only beginning. But there is still one final step, because everything we've discussed, everything we've imagined, everything we've prepared for remains incomplete until we go there, until we see it, until we reach beneath that ice. And that moment will not be simple. It will require technology we are still developing, missions we are still planning, challenges we have not yet solved. But it will happen, because curiosity does not stop because the questions are too important, and because Europa is too compelling to ignore. And when that moment comes, when we finally reach that ocean, we will not just be exploring a moon. We will be answering a question that has followed us for generations. A question that has shaped science, philosophy, exploration. A question that has never been answered. Until now. And whatever we find there, whether it is silence or something more, it will change us. Because it will show us what is possible. Not just for Europa, but for the universe. And for us. Because in the end, this journey was never just about a distant moon. It was about understanding our place in something much larger. And somewhere, beneath that frozen shell, in a vast, dark ocean, that answer already exists. Waiting, not to be imagined, not to be guessed, but to be found.